So let's make radicals very algebra-y today. We're going to do section 12.5, square roots of variable expressions. Variable expressions. The same idea applies with variables that applies to numbers. I actually think this is easier than numbers because I don't have to think about arithmetic. So we're going to take a look at something like simplify square root of x to the 7th power. That's a 7. So we can rewrite the square root of x to the 7th power as the square root of x, 1, 2, 3, 4, 5. I need 2 more. All right, so that's what it could be written as. And then we look for doubles. So double, double, double. All right, so I have a set of doubles. So I'm going to put that 2 for 1, taken care of. Set of doubles here, 2 for 1, taken care of. Set of doubles here, 2 for 1, taken care of. I have 1x left. So let's multiply this together. X times x times x, x to the 3rd, square root of x. Pretty easy. Another way of thinking about this is how many ways can you evenly split 7? Well, you can split it 3 ways evenly, but then you have the 1 left over. Just something to think about. All right, let's try a different one. Let's simplify the square root of x, y to the 5th over the square root of y. Okay, there's a couple ways you can go about solving this, but let's go ahead and use the process that we've been using. So we've got, for simple radical form, we cannot have the radical in the denominator, so you must rationalize or multiply by that 1. In this case, the 1 is a variable situation, but square root of y divided by square root of y is still 1. All right, so that gives us a y in the denominator. Now we've got the square root of x, y to the 6th. Let's simplify our numerator. Y to the 6th. How many y's are there? 6 y's. We're doing 2 for the price of 1. So how many doubles are there in 6? There are 3 sets, right? So we can write this as y to the 3rd. All the y's get to be taken. The x does not. Divided by y. And then we can reduce this fraction here. So that's equal to y squared square root x. All right, last one. Now we're going to make it really algebra-y. You like that? Adjective, adjective. Let us simplify the square root of, here we go, ready? This is going to reach way back in your brain. X squared plus 12x plus 36. So it is a it's a trinomial. It's a quadratic trinomial. So we're going to try factoring this guy. Factors of 36 that add to equal 12. If you need to do your x, that's fine. 6 and 6. So we can write this in factored form. X plus 6 times x plus 6. Do we have doubles of anything? Yes, we do. We have doubles right here. Look at that. So this would equal x plus 6. The book has you putting absolute values around it. I am not going to be picky about it now. When and if I see you in Algebra 2, it's going to make a big difference When we go to the next level, right now we're doing square roots, but when we start talking about cube roots and fourth roots and fifth roots, so on and so forth, it'll make more sense why you would be doing the absolute value. But for now, I'm not going to make a big deal out of it. I just want you to know that, hey, if I have doubles of anything, then that undoes my square root operation. All right, give that a try.